Hey team, we've got 5.7 today, matrix operations. So if you need to pause the video, but I'm going to kind of talk through some of this vocabulary that we've got going on here. Just some basic stuff. This is actually a very simple section. The only thing that's a little tricky is multiplying matrices together, but we're going to add them, subtract them, talk about sizes, which we've already talked about before. We have a row matrix, which just has one row and it looks something like this. We have a column matrix, it has only one column, it looks something like this. A square matrix is very self-explanatory. It can be any row that has the same, or any matrix that has the same number of rows as columns. So 2 by 2, 3 by 3, 4 by 4. It's called a square matrix. In a zero matrix, all the elements are zero. And by the way, this word elements, that refers to all of these numbers inside the matrix. So like those are technically called elements, okay? Also, matrices are equal if they are the same size, duh, and same elements, duh. So if you look at example number 1, this 2, this 4, this -1, well, 6 over 3 is 2, and 4 is the same as 4. -3 over 3 is -1. So these actually are the same, 3, 1, 0, 3, 1, 0. They're the same size, and they have the same elements. That is called equal matrices. Here's an example of not equal matrices. Okay, this is a 2 by 3. Remember, you name it like slope, 2 by 3. And this one is actually a 2 by 4. So these are not the same size, and that's what I wrote here. If you want to write down what the sizes are, this is a 2 by 3 because it's up 2 over 3. This is a 2 by 4. Okay, so very self-explanatory, very simple vocabulary to kind of talk about real quick. Let's go right into adding and subtracting. So we have some rules for adding and subtracting right here. They have to have the same dimensions. And you add and subtract corresponding entries. So this corresponding word is a word you should remember from geometry. That means same position or in the same spot. So like top left, bottom right. That's corresponding. And the result matrix is going to be the same size as this matrix and this matrix when you actually subtract them together. So I'm going to zoom in. We're going to talk about this one first. What I do want to do is kind of highlight so I can emphasize a little bit of what's going on. But this is a really common ACT question, actually, and there's really only one option to do this. You take this number and you subtract this number, and that goes in this position. So we're going to have a matrix that is the same exact size. We're doing -1 minus 5, which gives you -6. And yes, that goes right there in this position, along with all the other ones. So we're just going to line up all of our entries, our elements, and we're going to do the same thing. So I'm going to do 3 minus 0. That gives me 3, and that's going to go right there. Very, very simple. We're going to do 4 minus 1, which gives me a 3. And I'm going to do 2 minus 3, which gives me a -1. Okay, so very simple. This is a 2 by 2, by the way, and so is this one. And that means that my resulting matrix is also going to be a 2 by 2. That's what the same size up here refers to. Okay, how about this one? We have a 2 by 1 and a 2 by 2. Cannot add together. And the reason for that is because you don't have like enough numbers to match up, so you can't, they're not corresponding. Okay, scalar multiplication, that is the same thing. What you're doing is multiplying every single element inside by this 2. So you're basically doubling every single number in there, and the matrix again is still going to be a 2 by 2. So you just double every single number in the matrix. Careful, when you double 0, you still have 0. Okay, so super simple. Again, just some real quick stuff to talk about. Solving a matrix equation here is a really common ACT kind of a question. But we're going to do the same thing. We have to keep everything lined up and in corresponding parts. So I'm going to take the 2 and multiply it by the 6, and I'm going to add it to the 4, and I'm going to equal that to 10. And that's going to help me solve for x. So that's my first equation. I do know that you can hear some dogs barking in the background. That is them for your entertainment value. So I have 2x plus 4 equals 10. This is a very simple equation to solve. Start by subtracting 4. And that means that x equals 3. So we're also going to do the same thing, but with the y position. So notice how I'm kind of ignoring some numbers, but I'm selectively choosing specific numbers to be able to solve my equation here. So I'm picking numbers that are all on the bottom right of the matrix. So that's going to mean that 3y plus 5 equals 11. Sorry about the barking. 3y equals 6, y equals 2. You guys, that's Boiler and his girlfriend Nala, who we are babysitting right now. My house is going crazy. Okay, let's talk about this last part. This is the tricky part, you guys. That's why I put a little star next to it, matrix multiplication. We're going to do a couple of these here, and we're going to do a couple of them in class tomorrow just to make sure everybody's got the hang of it. So there's two rules to matrix multiplication. You can only multiply matrices if the inner dimensions match, and the result matrix, what your answer is going to look like, is going to be the size of the outer dimensions. So what does that mean? Well, you guys know how to size matrices now. So this 4 by 2 means that it actually has 4 rows and 2 columns, so it's a taller matrix. And a 2 by 3 means it has 2 rows and 3 columns. So that's the size of the matrices that we're talking about. Since these two numbers, these are called the inner dimensions. And they're the same. So that means that yes, we can multiply them. And our answer is going to be a 4 by 3. That's the outer dimensions. Okay, so that's a little bit tricky, but your two matrices, you have to know how to size them, which is why when we talked about the size of matrices, I said that there's a really important aspect to naming them by size, because when you multiply them, these two middle numbers have to be the same in order to be allowed to multiply them, and you'll see why in a second. And then your answer, what the answer is going to look like after you multiply them, is going to be a 4 by 3 matrix. So the order of these matrices actually does matter in the order of the two, the dimensions. So this one, our inner dimensions do not match. That means you can't multiply. Okay? And so this last one, inner dimensions, yes, they match. So that's good. My answer is going to be a 2 by 4. So that was a little bit weird, but let's talk about how to apply this. Let's look at this very first example, multiplying matrices. And here's what I'm going to be repeating over and over and over again, across, down, across, down, across, down. That's how you have to multiply. And what we're thinking in terms of the multiplication process here is I like to refer to it as distribution. So first of all, let's talk about the sizes here. We have a 2 by 2, and we have another 2 by 2. And that's because it's up 2 over 2, up 2 over 2. And so look at these two numbers match. That's a good thing. My answer is going to be a 2 by 2 matrix here. So anytime that you're multiplying two matrices that are the same size, the result is going to be the same size. So what I'm going to do first, here is kind of the weird thing, and here is where it gets a little tricky, is that we are going to take the first row and the first column and multiply them together. And that is going to go in the very first spot up here in my matrix. Okay, the top left spot is made of the intersection of the top row and the first column. If you would slide those together, they would be intersected right here. And so the weird thing is that we're actually going to kind of do this weird distribution thing. We're going to take 2 times 5, which is 10, and I'm going to add 4 times 2, which is 8. So I'm going to have an 18 in that top spot, but I'll do that in a second. Okay, so the next thing I'm going to do is, it doesn't exactly matter what the order is. If you want to do this top right spot, then you can do the top row and the right column. If you wanted to do this bottom spot here, you would do the bottom row in the first column, and then this last spot in the bottom right would be the bottom column, or bottom row and right column. So that's a little bit tricky, so let me kind of walk through the next example that we're going to do. I'm going to do this bottom spot here. So that's made up of the intersection of the bottom row. It's always across and down the first column. So what that's going to mean is I'm going to do 3 times 5, which is 15, plus -1 times 2, which is -2. So it's a little bit weird. So now what I'm going to do is the top row and the right column, and that answer is going to go right here. So I'm going to do 2 and 4 times 1 and 6. I'm going to start with 2 times 1, which is 2. And I'm going to do 4 times 6, which is 24. And then the last thing I'm going to do is I need a spot for the bottom right, so that's the bottom row and the right column. So I'm going to do 3 times 1, which is 3, plus, and I'm going to do negative 1 times 6, which is negative 6. Okay, so that means that my final answer, after I like combine all the like terms and stuff, I have 18 in the top left, I have 26 in the top right, I have 13 in the bottom left, and I have negative 3 in the bottom right. Let's try another one, because it is very confusing. I'm trying not to put too much like highlighting and too many swoops and stuff all over this matrix, just so it doesn't get too confusing, but let's try the next one. Notice that our resulting matrix for that last one that we did is a 2 by 2 matrix. It's the same exact size as both of the matrices that we multiplied together. Okay, so let's do this one. Here we have a 2 by 2 and a 2 by 1. And so since these numbers match, yes, I'm allowed to multiply them. My answer is going to be a 2 by 1. So my answer is actually going to look like this matrix. So I'm going to get lined up, get ready to go. And we're always, you guys, moving across and down. So my first row that I'm going to do, my first number, is I'm going to take the negative 4 times the 6, which gives negative 24, plus, and then I'm going to do 3 times 7, which is 21. And then in my bottom row, all I have to do is the bottom row and this only column here. So I'm going to do 0 times 6, which is 0. And I'm going to do 1 times 7, which is 7. So that means that my answer is negative 24 plus 21, which is just negative 3, and 0 plus 7, which is 7. Okay, let's do this one. We have a 3 by 3, and we have a 3 by 2. Remember how I'm sizing these as I'm going up 3 over 3, that means 3 by 3. This one's up 3 over 2, that means 3 by 2. Because these numbers match, yes, I'm allowed to multiply them together. My answer is going to be a 3 by 2 matrix. I'm going to start by going like this, and I'm going to do the first row and the left column. And all those numbers added together are going to go right up here. So it's harder when it's a little bit bigger like this, but my first thing I'm doing is 2 times 7, which is 14. And then I'm going to do the 1 times the negative 2. We're always going across and then down. So 1 times negative 2 is negative 2. And I'm going to do 0 times 1, which is 0. Now let's go in the middle row. I'm going to do middle row, first column, and I'm going to line those up right under here. I'm going to do negative 3 times 7, which is negative 21. And I'm going to do 6 times negative 2, which is negative 12. And I'm going to do 2 and 1, which is 2. And then to do the bottom row, I'm going to do bottom row, left column. So starting with 1 and 7, which is 7. And then doing 0 and negative 2, which is 0. And just adding all these numbers together, and then 4 and 1, which gives you 4. So now I need to do the exact same thing except using the right-hand column of this matrix. I'm going to go across down. I'm going to go across down, and I'm going to go across down. And that's going to fill in this column, this column, this column. I'm going to give myself a little bit more room. Now I'm going to do top row, right column. So 2 times 4 is 8. And then I'm doing 1 times 3, which is 3. And then I'm doing 0 times 0, which is 0. So that's those. Now I'm going across the middle, down the right. So I'm going to do negative 3 times 4 is negative 12. And I'm going to do 6 times 3, which is 18. And last but not least, 2 times 0 is 0. Now I just have one more to do. I have the bottom row and the right column, which means we're going to have 1 and 4, which is 4. And 0 and 3, which is 0. And 4 times 0, which is 0. All I have to do is like add all those numbers up. So my final answer is going to be going across the top column. 14 plus -2 plus 0 is 12. Going across the middle of the left, -21 and -12 is -33, plus 2 is -31. And going across down here, 7 plus 0 plus 4, lost my plus sign there it looks like, is 11. And adding these numbers up again is 11. Adding these numbers up is 6. And adding these numbers up is 4. So notice how we said our final answer was going to be a 3 by 2, and this is a 3 by 2. So again, moral of the story is, I know that was probably a little bit confusing. We will talk a little bit more about this in class tomorrow, but you're always going across the first matrix and down the second matrix. And when you distribute all of these to all of these, that's the numbers that you add up in the first position. And then I moved down and continued to use the first column. So I distributed all of these to these, and I wrote all of those here. And then I went down again, so across the first column, or first bottom row and first column, and all those numbers went here. So then to get all of these numbers on this side, I did the exact same thing except with the far right column. This and this, this and this. Let's do one more. I think you guys will like this one. And the reason for that is because this is a 3 by 1 and this is a 2 by 2. These numbers do not match. Therefore, we cannot multiply. Okay, so I know that was a little bit confusing. We will talk about this in class more tomorrow, but at least you have a basic understanding of matrices. First page of this section was very simple with adding and subtracting and multiplying by a scalar multiple, so like doubling everything. But this last part is tricky, so we will talk more about this in class tomorrow. Bring your questions. Thanks for watching. See you later.